Welcome back, everybody. We're continuing our chapter 12 notes, on climate and climate change, and we're continuing with section 4 right here. We've talked a little bit about why we study the climate and some of the various climates that are on the Earth. Now we're going to be talking about what the various studies that we've on Earth about climate change actually mean and what it's doing to our climate as we speak right now. A couple of your vocab terms in this chapter are the three terms you see in front of you right here. Three various records, that is, things that we use, that is, sources of data that we use to study climate. We've got the instrumental record, the historical record, and the paleoproxy record. So I'll describe those in just a second here. The instrumental record means a record of data about climate as taken by human instruments. Things like barometers, thermometers, humidity tools, and that kind of thing. The historical record is the record of the conditions of the environment and the atmosphere and the climate as told by people and written down in things like books and newspapers and articles and that kind of thing over the course of history. This goes back only a couple hundred years. And finally, the paleoproxy record. That sounds like a kind of a complicated name. Paleo means ancient, like paleontology. You study ancient animals. And proxy, it kind of has the same word that proximity has in it, that is close by. All right. Well, paleoproxy means it's a record. It's not a direct record of climate, but it's a record based on things that are nearby. For example, like tree rings. All right. If you study tree rings don't tell you exactly what the climate was like, but based on the thickness of tree rings, you can get an idea of what the climate was like. So it doesn't tell you exactly what the temperature was, but you can use this proxy, or that is this related information from other sources to get an idea of what the atmosphere, what the climate was like. All right, so we have these kind of measurements of the temperature of the atmosphere from 1880 all the way up to the present day. And we can see that it goes up and down, it varies a lot, but generally speaking, the trend is up. So the temperature has been warming over the past several hundred years. As I mentioned a minute ago, so a paleoproxy or paleoclimate data sources. Good examples of them are things like tree rings. All right, how thick tree rings are at various years, and you probably know that every year a tree grows another ring. That can tell you about the climate at various years ago, how thick the rings were, and even ancient trees that are dead, the fossilized trees, we can get an idea. So we can get records back to tens of thousands of years ago. Sediments in lakes and oceans tell us about the climate record in ancient times, and also ice cores. Here's where we have the cryosphere. Remember we said cryo, C-R-Y-O, means anything dealing with ice or frozen. So we've got the atmosphere interacting with the cryosphere, and the cryosphere, layers of ice, telling us about what kind of particles and what kind of gases were in the atmosphere many, many years ago. So one thing we can do, and this is another vocab term that you have, which is called dendroclimatology. That is, we can compare tree rings from different things. For example, a Native American home might have a log beam in it, maybe a dead tree, maybe a living tree. But all of these overlap in terms of their ages at one time. And so where we see parts of the tree rings, that part right there and that part, and this part right here kind of matching up, we can put together a record of what the climate was like. Was it warm? Was it cold? Was it favorable to growing? Was it not? And so forth. So this is called dendroclimatology, using tree rings to determine what climates were like in past years. Here are scientists studying sediment cores, all right, so drilling down into lake beds and getting sediments and analyzing what those are made up of, and also ice cores as well. Scientists work in frigid environments to analyze ice and see what climates were like years ago based on the kinds of things they find in the ice. So some of the things that can be found in either sediments or ice cores are things like pollen. All right, pollen is an indicator of how well plants are growing and what kinds of plants are growing. Pollen goes into the air, and many people who have allergies know that during the spring there's a lot of pollen in the air. Another record we can look at to determine what the climates were like in years past is corals. All right, corals the calcium carbonate that the coral animals use to make their homes, the hard shells, contains all kinds of isotopes that tell us about what temperature was like years ago. Carbon-14, you may have heard before that carbon-14 can date, like carbon dating. Carbon-14 can date ancient objects, ancient fossils. So this is a type of isotope, a type of atom that as it breaks down, it tells us how long it's been around. And also carbon dioxide as well. Carbon dioxide, you probably know to be a greenhouse gas, right? And the more carbon dioxide is found in ice core samples and in the sediments, the more it indicates that it could have been warm because carbon dioxide helps to trap heat in the atmosphere. Both of these graphs right here show an increase in carbon dioxide in the atmosphere. ppm, that means parts per million. Parts per million. So say you have a million, you might say parts of the atmosphere, a million pieces, or say a million atoms, as it were. That would tell you how many of those million atoms are carbon dioxide. So 310 or 400 or so out of a million doesn't seem like much, but carbon dioxide does have a big effect on the atmosphere, and so it doesn't take much to cause the temperature to go up. And this graph right here shows us that air temperature and carbon dioxide are very closely correlated. As carbon dioxide goes up, air temperature goes up. As it goes down, air temperature goes down, and so forth. So an increase in carbon dioxide is really a good indicator of what the temperature would have been like during paleoclimate times. So what we can do to determine what climates are like is to create models, is to create computer models or mathematical models. So we know parts of the atmosphere affect other parts of the atmosphere. And so what we can do is break them down into chunks or boxes or cells. You might say if you have a warm cell right here, a warm chunk of the atmosphere, and it's adjacent to or next to a colder cell right here, well, that means that we know that the heat flows from high to low, and so this cell is going to make that cell warmer, and the original cell is going to cool down. And so cells affect each other that they are adjacent to. So what computers do is they break the whole atmosphere into a giant stack of boxes. We call them cells, or you might say chunks or parcels of the atmosphere. They can vary in height from the bottom of the atmosphere all the way to the top. Many of them are very large, but each cell is assigned a certain amount of data. That is temperature and humidity, amount of this gas or that gas, the pressure. And so each cell is kind of its own little piece, and it can affect other cells around it accordingly. So what we can do is we can run climate models to determine what the cells are going to do if they have certain properties. Temperature, gases, humidity, pressure, so on and so forth. We can run them forwards, but we can also run them backwards to see what historic climates were like. So these models, these computer models, can help us predict climate change. Unfortunately, what they can't predict is they cannot predict human behavior. And human behavior has been churning out more and more and more things that affect our climate, especially carbon dioxide. And so that's the real X factor in here. Well, we can predict what the climate will do if humans don't interfere, but the fact that human interference is taking place, that throws a real wrench into the works and really makes it difficult to exactly know what the climate is going to do. Although we can say human impact is certainly making the climate warming up. So here's a good little graphic right here of the various cells of the atmosphere. So you take the Earth and you take the atmosphere and you break it down into all these little cells, all these chunks right here, and there's millions and millions of them all around the Earth. These imaginary cells. Well, we need computers to manage all them and manage all that data. And so, in fact, some of the most powerful computers in the world are dedicated to generating climate models based specifically on this, on all this data right here, all this cell data.